At Checkerspot, we make oil. We make oil that is an alternative to petroleum, to fossil fuels.
So we have the ability to have high-performing materials that have a lower footprint and less of an impact than typical incumbent materials.
Microalgae is really unique from a material science standpoint. There's the ability to grow whatever we want through the molecular foundry to really drive material innovation from the molecular standpoint. But then looking at just the material that we're using today in a single strain looks more like a petrochemical material than it does a biologically sourced material. And when it gets to using that material in applications and formulating, it's so much more reproducible than most things that you would work with from a biologically sourced material.
We'll look at what types of manufacturing equipment they use, what are the performance characteristics, what's important. We do that with material science, and typically we'll bring them into the discussion directly with the customer. And then we'll zero in on what formulation do we need to develop that fits the application.
And that's the beauty of polyurethanes, is that there's so many different levers that you can pull to tweak and tune the material properties. Cast polyurethanes and foam polyurethane materials, from the chemical bond level up to the macro scale level, allows us to iterate so quickly that we can formulate, test, and take things from really the lab scale into the industrial scale and really drive performance.
Seeing companies that will take a small risk using a new material and then expand and start expanding into new product lines really validates what it is we're doing.
I think what biotechnology and adjacent technologies are bringing to life through applications is that we can actually achieve performance properties that haven't been available before, to demonstrate that performance versus sustainability is a false choice.